Well, let's see, I just spent a bit of time on the phone, quite a bit of time on the phone with my buddy Scott. Scott's a very good technician. We're shooting the breeze about all sorts of things, including this radio. And I was saying, one of the things I wanted to talk to my buddy Scott about is just how does AVC work in an FM receiver. I can't fathom it myself because adjusting the amplitude of the signal coming through the radio shouldn't have any bearing on the output. That's what FM's all about. It's all about AM doesn't matter, and frequency modulation is what is detected at the end. And while we're chatting about it and pretty much agreeing that there can't be an AVC like there is in a AM radio, Scott suddenly says, well, the volume's going down. That can't be from the RF part or the IF part. It's got to be in the audio section. It's got to be in the detector or something in that area. It has to be there because if the FM signal were becoming weak, what we would notice is more hiss coming in. Well, anyway, that was the nature of our discussion. So this has caused me to think about the detector circuitry and the tube in the detector, which is a 12 AL6. AL5 rather. AL5 type tubes are really common, especially the 6 AL5. And I have a big whack of them. Look, here they are over here. Almost all of these tubes you see are 6 AL5s. There's a couple 3 AL5s in there. Well, I don't have a 12 AL5. And, that's not so common. So then I started thinking, well, what happens if you throw a 6 AL5 in where a 12 AL5 belongs? The pinout is the same, but obviously the heater is not. The 12 AL5 runs with 150 milliamps. The 6 AL5 runs with 300 milliamps, twice as much current. Twice as much current, half the voltage, you get the same amount of power, same amount of heat. And certainly if you had a radio that used 12 volt heaters coming from a transformer and you stuck a 6 AL5 in there, it would overheat because the voltage would be too high. But wait a minute. This has no transformer and it has tubes in series. It has two sets of tubes in series. The radio tubes are in series. They're all 12 volt filaments. They're all 150 milliamp filaments. And they don't add to 120 volts. They come up short. They add to 400 volts. 400 ohms rather, ohms. And the rest of it is taken care of with either this resistor or this one up here. If I looked at it for a while, I could figure out which one of the two it is. This white thing here. This other one up here appears to be the guy that's caused all the extra heat. So, in fact, I can see that this one runs into these tubes. So this is the resistor that compensates for the 12 volt tubes not adding all the way to 120. It turns out it's a 380 ohm resistor, so it's 400 in the tubes and almost 400 there. So what happens now if you take out the 12 AL6 and stick in a 12 AL5 and stick in a 6 AL5? So I did a few calculations, and assuming the line voltage is 120 volts, and assuming this resistor really is what it's supposed to be, and assuming all the heaters are what they're supposed to be, it hardly makes any difference. The heater current would go from the nominal 150 milliamps. In fact, it's not quite 150 milliamps, slightly higher in this radio, to 170 milliamps. 150, 170, you know what, that's virtually no difference. Now, the 6AL5 itself is going to run cool. It's going to have roughly half the current going through the heater that it's really designed for. That'd be great if I had a 12 AL5, but I don't. Because what I'm suspicious of is the detector tube is the problem. Goodness knows how poking around in the IF can somehow cause the detector tube to act up. But the fact is, I've never replaced it, never checked it in any way. I don't think I even put it into a tube tester. Can't remember now. So what I'm sitting here pondering is, why not plug in a 6AL5 where the 12 is. The radio may not operate as good as it should, but it would be interesting to see if it has a output drop-off. And if it doesn't, then I think I can conclude that the 12AL5 has been the source of the problem this whole time. At least I can eliminate it if I plug this in and the radio should happen to work well enough, and then I hear the fading again, which is kind of what I expect, frankly. I would be able to eliminate the 12AL5 as the source of the problem. What risk is there to the radio? I don't think there's much risk at all. Is there much risk to this tube? No, it's going to be running cold. All the rest of the tubes are going to be ever so slightly warmer. Not enough to even fret over. In fact, if I'm really worried, you know what? I can run it on restricted power. And, I could do that. Then the heaters are certainly not being strained. So, that's such a simple thing to do. Low risk. I should do it. So I'm going to do it. I just convinced myself. So let me grab a 6AL5. Maybe I should run this through the tube tester first. Okay, 6AL5. Yeah, I think I'll run it through the tube tester. And assuming it tests good, bingo. Okay, so I tested a number of them. They're all testing pretty low, but this one tested pretty high. And with my tube tester, I turned down the voltage because I think the voltage drop on this is going to actually be low, quite a bit low. So this is going to run really cool. And I just turned it down to 3 volts instead of 6. And the thing really fell off. But I'm going to give it a try anyway. If I blow it up, I don't really care. As I said before, I don't think there's much risk here. So we'll pull out the 12. And you can actually test the 12AL5 too. Yeah, 12AL5. It's easy to test. I'll put in this guy here. It says Rogers on it, which is a Canadian brand. It says Great Britain on it. Interesting. Stick it in there. Now remember, I can only get away with this because these tubes are in series. And the current is aimed for much less than what this tube is designed for. Okay, now we'll start it up on restricted power, but first let's test the 12AL5. And, just to be sure, let me look it up on my... Yeah, let me do this properly. I won't just pop it in there with a different heater voltage. Turns out it's exactly the same settings, except the filament voltage. So we'll plug it in. Checking for short circuit. Might as well take a look. What's going on? Oh, that was stupid. Wrong control. Okay. Tube test. Point hole. Test really good. Okay. Oh, I was going to hold that for a while. What would I possibly hope to see? I don't know. See the tube start acting up. I don't think that's going to happen. Okay, another crazy moment in Jim's shop. I'm going to set this one here. Don't want to mix it up with all those other tubes. We're on restricted power. We're going to be on restricted power. There we go. What will happen? I don't know. Turn the volume up. When it's good and loud, 2 is enough. I got it on 4 here. will this radio work? Is that tube glowing like a light bulb? Was I totally wrong about those? No, everything looks fine. There's a chance the radio just will not work. That tube just won't get hot enough to do its job. It's just a diode, so. The moment. The moment we've all been waiting for. We're still waiting for. Okay, heck with restricted power. Actually, it takes a long time to warm up on restricted power. So patience, patience. Okay, what do you think? That's enough patience? That's enough patience. Here we go. Come on, little radio. Actually, this is kind of a big radio, isn't it? You can do it. Play me some radio here. Big ugly hum. Well, not a big ugly hum. Let's just check the AM side. Doing its usual thing. Back to FM. I don't think it's too happy with the situation, is it? But the thing is, I'm trying to eliminate a problem here. Well, I don't think I'm really doing I'm doing much good at all. Let's tune it around. Just maybe it's not tuned right. Oh. Leave that on there. Probably the CBC is playing music at this time of night. Somebody's got advertisements on, don't they? Well, the radio's working. Now, I got it turned way up. It's almost full blast, so this should be blaring in here pretty darn loud. Now, the question is, will it fade out? Is it even running at full volume? So, let me just keep it quiet there. Maybe you can barely hear that. Let's give it the poke test. Maybe it'll go loud. Wasn't it quiet last time I started up and then I got it to go loud? Poke test. Well, it's not getting any louder. I'm not even sure you guys can hear that. Or you guy. This thing had to play for a long time before the fade out occurred. So I could leave it here playing and come back in a while and see if the fade out occurred. If the fade out occurs, then we can eliminate the 12AL5 as being the problem. If the fade out doesn't occur, then, well, maybe the 12AL5 is the problem. Oddly enough. How that could be, I have no idea. I'm way up in a different part of the circuit. You know, if I touch the IF here and the radio does quiet down, the whole notion that this problem has to be in the detector or the audio circuits is totally wrong. Because if I'm detuning, not so much detuning as weakening the IF signal, you think the output would get weaker. I just don't know. I just don't know. Yeah, so I think I'm just going to let this play for a while. I won't bother recording the voltage on here. Just going to turn it up and leave it for a while. Okay, shame on me. I went to watch a short Vice documentary. It turned out to be a 40-minute documentary on the Congo. And this is what's happened here. It's just fallen off. I used up too much of my paper here. So, having changed that tube didn't help one bit. On to the next idea.